Our next speaker is Maria Salgado. You all know Maria, I guess. Maria is from Salamanca, a great university and educational town. She moved to do her PhD in Madrid in the Carlos III Institute, where she got it, and then she moved to to Baltimore to work at the Johns Hopkins University in collaboration with Joel Blankson and Bob Silicano as well. And then she moved back to Spain. But in this occasion, she didn't move back to Salamanca or Madrid, but she came to Barcelona, where she's working now at the IRSI Caixa, where she's really involved in aspects related to HIV cure and remission. And she will be talking about one of the cohorts that she is mainly leading a great effort in terms of HIV-infected individuals who got an allogeneic stem cell transplantation. So thank you.
Thank you. Well, first of all, I would like to thank the organizer to give me the opportunity to be here in this great session, talking about our results in the system cohort and IRSI Caixa. So the title of my talk is a question: is possible an HIV cure with a stem cell allotransplant? And the answer, I think you know, the answer is very short: is yes. We have the case of the Berlin patient that all you know. Here is Timothy Brown that you can see here with Javier a couple of weeks ago in a meeting. In this case, most of you know the story. He received an allotransplantation due to leukemia with a donor that has a mutation in the CCR5 receptor. This was done by Gero Hutter and their team. And they stopped the antiretroviral treatment right after the transplantation. What they saw is the cells from this patient were changing from having this receptor and being susceptible to the HIV, and after the transplantation, the cells were not they were resistant to the infection, the HIV infection. So right now, today, 10 years after this transplantation, this patient is still alive, is well, and is out of any antiretroviral treatment and with no virus in his plasma. So let's move then the question to: is possible to cure HIV with a stem cell allotransplant again? And this is the more difficult question to answer. So going back to the story of Timothy Brown, I would say that it was two main causes that this transplantation was really successful to cure HIV. One could be the fact that the transplantation was done with a mutated donor, with a CCR5 mutated donor, but the other could be also all the transplantation associated factors. So there are now different cases that can give us some idea if one or the other have a major role in the transplantation. So going to the transplantations that have been done with the CCR5 mutated donor, this is a case that we did in Barcelona a couple of years ago, and how we started to work in this. This was the first case of a transplantation with a mutated cord blood donor. In this case, this was done in collaboration with Rafael Duarte and the team in Belviche in Barcelona. And they did a transplantation to a patient with a cord blood unit associated with CD34 positive cells from a sibling, helping to do all the transplant with the cord blood. This case is actually very interesting because he was a journalist that heard about the case of the Berlin patient, and he came to the doctor and asked that he wanted to be the second Berlin patient. Unfortunately, for this patient, the cancer progressed, so he died very early after the transplantation, just 3 months after the transplantation. But still, we follow very intensely this patient, and we could get some results. So before the transplantation, we were able to detect viral load. Still, he had like 300 copies, and after the transplantation, we just saw 3 copies of ultrasensitive viral load. And more intensely, in the proviral HIV DNA that it was detectable before the transplantation, it got undetectable. So like this, we start to think that maybe it could be possible to know a bit more about the transplantation. And this is the other case that has been reported, transplanted with the CCR5 mutated donor. In this case, this was very similar to the Berlin patient case. It was a transplantation with bone marrow mutated in the CCR5 gene. And in this case, as you can see, they stopped the treatment as well around the stem cell transplantation, but in this case, the virus went up. And what happened is apparently it was a small amount of X4 virus in the plasma of the patient, and the virus moved to the X4 tropism and proliferated, and still it was not as successful in the Q as it was the early patient. So with these two cases, we have the idea that something else needs to be there to cure the patient. It was not only the CCR5. And so going through the other associative factors for the transplantation, I want to check all the other cases that have been studied that for patients that have received HIV positive patients that have received a lot of transplantation, but they didn't receive the mutation in this. So far, there are 6 cases reported. 2 are the most well-known, the Boston patients, and this year, actually, this month, just came up a paper for another patient in Minnesota, and then there is another report for 3 cases in Australia. I'm going to go through that a little bit. So these are the Boston patients, the more famous ones, and very important thing that happened in these patients are like after the stem cell transplantation, as you can see here, the provider HIV DNA it got undetectable, and this is the first approach that actually achieved this. There is no other approach right now that we are trying, either latency reactivators or checkpoint inhibitors that achieve this thing. So both of them became undetectable, and not only that, when they stopped treatment, even if the viral load went up, it took a long time. It took for one of the patients 12 weeks and for the other 32, which is really delayed comparing with the could happen in a normal patient that is under treatment. Going to the patient to Minnesota, very similar results. After the transplantation, this is infectious units, this is the QOA, but still is the same results with the provider HIV DNA. The reservoirs went down and became undetectable very early after the transplantation. And the same, when they stopped treatment, in this case it took 41 weeks, very similar to other patients in other places, in other transplantation, but still very similar delay in the viral rebound, so very delayed. And this is one of the cases from Australia. This is like, sorry, it's a little bit busy, but you need to focus here. That is the provider HIV DNA. So this patient is under limit of detection after the transplantation. And in this case, the patient reported that he still was having the treatment, but when they checked the antiretroviral levels in blood, they didn't detect the drug. So when they saw, then after a few months, is like the viral load went up as well. Now this didn't happen in the other 2 patients that they studied, that they are still under antiretroviral treatment and still with undetectable reservoirs. So what we learned is that the allotransplantation by itself is able to reduce the reservoirs. So this could be what we see in the regular patients. Usually in the clinic, you can see that after you take the treatment, in some point the viral load is undetectable. But we in the lab doing our test for provider HIV DNA and our culture, still we are able to detect virus in cells and even in tissues. After allogenic stem cell transplantation, it seems that this is reducing and we don't detect any reservoirs. What we expected is when we stop treatment, the virus is not coming out, but this is not happening. It's coming up, but it's still coming up more delayed way that it used to happen, or it's happening with regular patients. So the question is why this is happening? What's the key factors that make that after a transplantation, the patients have this very reduced provider HIV DNA. So to research this, we create, like 3 years ago, the consortium iSystem is a consortium that is from different groups, research groups from all Europe, and even now starting to integrate Canada, and we are starting to get patients from Mexico even. There are hematologists, virologists, and infectologists from all over Europe. And this is an observational study. We don't change the regular treatment for the patients for the cancer. We just follow in a virological way what is happening all the way through the transplantation. So in this case, we evaluate and the patients, we get a large amount of samples from different time points, and then we in the lab do the research in immunology, molecular biology, and cellular biology. And also, when we started in the project, it was a great effort to do some more donor testing. So right now, thanks to different funders, we were able to test different cord blood banks, and also thanks to the KMS, the place that Gero Hutter is working right now, they test a lot of bone marrow as well to have a large amount of cord blood or bone marrow that we know right now that they have the mutation for the Delta 32. So one of the works that we do in the consortium is when we receive any patient that really needs a transplantation, we try to search for one of these units to do the transplantation with a mutated unit. Still, if there is no possible, we follow the transplantation anyway. So right now, we are 14 clinical sites, 7 different labs in 8 different countries. And in the cohort, we have right now 24 transplanted HIV positive patients. From those, 13 patients are alive and in follow-up, all of them with antiretroviral treatment. As you can see, like the mortality of this kind of approach is very high. That's why we just follow the patients that really need the transplantation. This is a very busy slide, but I think you can get a lot of information of the patients that we have. These are the 24 patients. The lines that are with the arrows are the ones that are still alive and we are follow up. As you can see, there are some of the patients that they were transplanted more than 5-6 years ago, and we still follow up. Some of these patients actually enter in the cohort after the transplantation. We didn't follow them from the very beginning. Still, we think they are very interesting to know what's happening after also. As you can see here, from all the patients that we have in the cohort, 6 received the transplantation with a mutated donor, and 18 still wild type. And most of them were transplanted with adult donor. Just three of them received the transplantation from the umbilical cord. So in different time points, we try also before the transplantation, but even after, we receive large amount of blood. We do leukapheresis, and we receive also different tissues. And this is a big difference comparing with the other patients or the other papers that I showed you before. We check the reservoirs in different tissues. I'll show you later. So our objective is to investigate the exactly factors that are actually implying in reduce the reservoir in this kind of patients. We check 3 main factors, 3 main associated factors to the transplantation. One is the nature of the stem cell donor. This could be bone marrow or cord blood cells, because the allogenicity of both different tissues are different. Other one is the time to reach the full donor chimera. And this is the time that the donor cells reach to have the higher 100% in the recipient. And last one is what is called the graft versus host disease, which is a strong immune reaction that can happen in a transplantation that needs to be balanced. It's very helpful to kill the tumor and to help the patient, but if it's very strong, can be very bad for the patient as well. So going back to this slide, from the 13 patients that we have, we took 6 patients that are the ones that they were in follow-up for more than 2 years. So they were very well. They were all of them transplanted with CCR5 wild-type donor, and all of them still under antiretroviral therapy. These patients, all of them had a lymphoma. That was the reason why they received the transplantation. One of them received a cord blood transplantation, all the other bone marrow, and one of them from unrelated donor. The follow-up from 2 to 7 years. And this is another very important thing because it's different to the other patients that I showed you before. All of them are in remission and out of any immunosuppression. And this is very important to realize that the patient has their own immune system right now. They are not balancing the immune system. So as I said before, we got peripheral blood, but we did a large amount of blood. We did leukapheresis, but also we received samples from gall, bone marrow, lymph node, and CNS. And in those tissues, we mostly check the proviral HIV DNA. And in peripheral blood, we also check a viral load, ultrasensitive viral load, and viral outgrowth. I need to point out that in each tissue, we try to isolate the main target for the HIV. So in the case, for example, of the ileum in the gut, we isolate CD45 cells. This is, we prove recently, we published this recently, that when we isolate the cells that are target for HIV, we have very much better sensitivity to detect the HIV. So in each case, we isolate the cells for better sensitivity. So these are the results that we obtain. In here, you can see the open symbols that you see means undetectable, and the different levels mark the limit of detection in this case, because it's based on the number of cells that we receive or we obtain in each case. So as you can see, 5 of the patients were undetectable for provider HIV DNA, also for the viral outgrowth assay, and also undetectable for the ultrasensitive viral load. When we go to the tissues, we saw that all these 5 patients were also undetectable in ileum, CSF, lymph node, and bone marrow. But there is one patient that still was positive in blood. Still, we were able to detect provider HIV DNA and viral outgrowth. This patient, we didn't get cells from tissues for ethical reason, because we already proved that it was positive in blood. So our objective was to check what was different for this patient comparing with the other one. So these are the 6 patients, and the reservoir, as we said, and the patient 1, it was the one that it was positive. So all the patients that were able to eliminate the reservoir, or at least make it undetectable, all of them received a bone marrow transplantation, whereas the patient number 1 received a cord blood transplantation. The patients that were able to reduce the reservoir have a very fast, rapid full donor chimera. All of them during 1 year, but even 3 of them within 1 month. And also, 4 out of 5 of these suppressed patients, they have some type of graft versus host disease, either acute or chronic. I have here a couple of examples, so you can see, and you can see how we got these conclusions. So this is patient number 3, and you can see that it was positive before the transplantation for provider HIV DNA. In this case, in blue you can see the percent of donor cells. So this is the reaching the chimera. And you can see here that within a month, this patient received the cells, and it were full donor chimera, which is very important as well for the success of the transplantation. So right after this moment, next sample that we had, it was already undetectable for provider HIV DNA. This is actually nicer in this patient, that as the provider HIV DNA was even higher, and still we were able to detect some traces of viral load before the transplantation. And this patient, during some time here, a couple of months, has some problems to reach the full donor chimera, and to the transplantation, it was still not that good. So in this moment, the doctor stopped the immunosuppression to provoke the graft versus host disease always in control. In that moment, right in that moment, you can see how he reached the full donor chimera. The provider HIV DNA was undetectable, and also the traces of viral load that we detect in plasma, they become undetectable as well. So to conclude this part, we saw that the transplantation by itself can reduce or the provider HIV DNA, and the way to do that is for different factors related with the transplantation that are related with the alloreactivity. So at the end is the immune response that is happening against the tumor, but also is happening against the HIV, which is we call the graft versus HIV effect. So right now we have here all the patients that they presented before, that they rebound in some point, all but the Berlin patient, and we have here 6 patients that we have in this cohort, and still they are all antiretroviral treatment. So some questions that we have as well is what happens if we stop the patient of treatment. But before to go through this other part, we wanted to mimic in the lab what could happen after if we stop the treatment. So we designed, with the help of my former mentor Joel Blackson, this assay in the lab that is based in and do a transplantation of the cells from each of the patients that I told before to the mice. And in the mice, without any antiretroviral treatment, see what's happening if the viral load is coming up. We did this for the 6 patient, also for a patient that it was positive for HIV but on antiretroviral treatment, and it was suppressed in plasma viral load. So these are the results. This is our positive control, our normal patient, let's say, and right after we infused the cells from this patient in the mice, we saw right 2 weeks after that the viral load was really high. Also, we were able to detect proviral HIV DNA in blood, and also when we sacrificed the animal in the spleen. But this is not happening for all the other 6 patients in the transplantation. So we think that still we can see probably a delay. We cannot conclude that it was not a viral reactivation, but still probably a great delay in the reactivation of the viral load in these cases. So how could we apply this knowledge? Because you can say that the transplantation is something that we cannot do for most of the patients, but still within the cohort, with the consortium, we think that we can learn a lot about this type of patients. And for sure we can apply this. So yesterday you saw the talk of Paula Cannon, that it was amazing, about how there is a new line about editing DNA editing and transplanted, like do an autologous transplantation to the patients with the CCR5 mutated. So it seems that actually to help this may be necessary to do some immune suppression. So even at the same time, here in Spain, in collaboration with Daniel Bachiller and a group also in Basque Country, we are trying to do also some gene editing using talents in this time, and do some gene disruption to be able to eliminate the CCR5 gene for the patient. So what will happen is the idea is to obtain cells from the patients, mutate them with the talents, and then put the cells again in the patients. This slide is actually not from us. This is from from the first clinical assay that was done using this technique from the Sangamo company, and they did exactly this type of approach, but with zinc finger nucleases. And what they saw is right after they stopped treatment, all the patients rebounded, but some of them rebounded a bit later than it was expected. So still there is opportunity, and as you saw yesterday, there are a lot of research in this field as well. So to conclude, just to take home messages, we saw that allotransplantation in the patient is really the only one approach that achieved to cure one patient, even reduce the proviral or the reservoirs in a lot of patients already, and even when they stop the treatment, delayed the time to the virus come up. In our study, we were able to see why this is happening, and it's mostly because the alloreaction during the transplantation, but also to have a CCR5 mutated donor could help very well in the case that there is any reactivation after all. And all the knowledge that we are getting within the cohort, I think, will be very useful to design new strategies. I just wanted to thank everyone that helped in this project. That is a lot of people, everyone in our campus in Canruti, and mainly Cristina Galvez, that is doing the PhD with us and is there in second line, and is helping a lot with this project. And also everyone in the iSystem consortium. Javier and Maria are the 2 PIs in the consortium, but Jose Luis and Micon in the Gregorio Marañón, they are doing a lot of wonderful job, and most of the patients are from there, and also from John and people from Granada and people all over the Europe. It's a lot of work, coordination, a lot of work from a lot of people, and I present, but there are a lot of people behind this. Thank you very much.
Thank you, Maria. So this presentation is open for questions. Ron?
It's my recollection that the Berlin patient received a second round of bone marrow ablation and a second round of
Yeah.
bone marrow. Isn't it possible that that second round was critical for achieving a more complete elimination of the reservoir and more complete ablation?
It might, yeah. I mean, what we saw is as soon as you get the full donor chimera, is better, but still, our case, in Barcelona case, I didn't show the whole line, but it happened something very similar. The first cord blood that they infused, it didn't work as well, but they had to infuse a second cord blood, and what happened in the second cord blood, that it didn't work that well, the second one, but the first one in that moment went up, and it worked very well, the first one, and it was the moment that we actually saw that the reduction in the proviral HIV DNA and all the tissues that we saw. So definitely, maybe second infusion or second transplantation can help always.
Yeah, I mean, I would think it's easy to imagine that with one transplantation, somehow you do have a transmission of a couple of virus particles
Yeah.
to the donor that can, stay quiescent and then when relieved can come out. But if you do a second round of ablation, then you get those eliminated too, and that's key could be key for the success.
You need to think that each transplantation should be like a strong immune response, the alloreactivity. So the way that I think is, if you have the first transplantation and didn't was that strong immune response, even to kill the tumor and to graft the cells in the body, the second one will help, and it will be second round of strong immune response against the tumor, but also the HIV.
Maria, great work. Congratulations. I have one clarification. The 6 patients you showed were grafted with a wild type CCR5 donor. Okay. No, I have a question. It's a provocative question. I'd like to share with you my own concern. It has been described that Delta 32 patients, homozygous, well, they are more susceptible to West Nile, but also that when they are grafted, for example, with a kidney transplant, they react less against the transplant. So in some way, it looks like if these Delta 32 patients display lower anti-transplant response. So my question is, have you observed in the patient graft with the Delta 32 cells, there is a less graft versus host disease, or the level of graft versus host disease is the same?
No, like Berlin patient had graft versus host disease, for example, and the one that we have had mild, but also has some graft versus host disease. We didn't observe that, but still each patient is like each transplantation is really different from the other one. Within the cohort, we are trying to have some conclusions, trying to join more number of patients. But so far, we didn't see that they have lower reaction, or still is. Sometimes this is provoked from the doctors. They stop or reduce the immunosuppression to try to provoke the graft versus host disease, because a little bit of this is very good for the tumor as well. So it's a balance that they try. They are very good doing this and try to balance all the time to kill the tumor. It's helping as well to kill the HIV, but still the patients can survive this.
Maria, thank you. That was beautiful. So if we can be pessimistic, you have patients that undergo full ablation. They become fully chimeric with the donor's immune system. You cannot detect HIV using the assays we currently have, including, I think you said 250 million T cells put into a mouse.
Yeah.
So, but the experience so far, apart from the case of Timothy Brown, has been that all these patients will eventually rebound, which would therefore be a prediction. Where do you think this virus is hiding?
Where? Tissues, for sure. Tissues, for sure. There is some very nice data from Monique, that is in the cohort, Monique House, that they had one of the patients that passed away very early. They had the opportunity to do a necropsy. So when they took the regular amount of tissue that we have, like biopsy, they didn't detect the virus. But when they had the material, so they were able to get more material and then check the provider HIV DNA and other techniques, they were able to detect mostly in every tissue in this patient. So we don't have the techniques to collect the samples that well from the tissues, and still I think the virus is in the tissues. And that's one of the limitations of our study in the mice, because we get the blood. We still we thought about try to get some tissues, but we never get that many cells from the tissues, and still we get that little cells that we can check provider HIV DNA, but still we don't get that many. Our idea is right now in January we are meeting all the consortium to try to think about next step for this patient as well. And the idea is to combine, not just stop treatment, combine with any other immune response to help if there is any rebound, to help the immune system of the patients to control that. We are evaluating that because stop treatment by itself, it was already done, it's proved that it takes 4 or 5 months to viral rebound, and that's
But it will
that
come back.
happen.
Yeah.
Just a short question.
Hello.
Yes.
What do you think about the role of the macrophages in the reservoir? It is possible that the transplantation didn't prevent the viral rebound because the virus switched from T to entropic? Thank you.
From the tropism of the... We are checking the tropism as well. Macrophages, I mean, for sure has some role, and even in our lab we are studying the role not as much as reservoir, but communicating or moving the virus from different tissues to the CD4 cells, and it has really important role in that. We are not checking specifically that in this project, but because we are not observing the provider HIV DNA in CD4 cells, that is the highest reservoir. So it's much more difficult to find even in other, and even isolate macrophages, you know, that is very difficult. But yes, probably, mostly we see in the data that is a good role communicate, like moving the virus to the CD4 cells, doing the connection.
Okay, we have to move on. Thank you, Maria.
Thank you.